In this video, we will take a quick look at an actual real-life example of fouling on a heat exchanger. This device is located in the engine bay of Toyota Priuses and it is called the EGR cooler. EGR simply stands for exhaust gas recirculation. Most modern vehicles have an EGR system since they help reduce air pollution. Right here in the red circle, we can see the heat exchanger that we are currently talking about. Right in front of it, there's an EGR valve that helps control the amount of exhaust gases that are allowed to pass through the system. This whole system is designed to recirculate the hot exhaust gases that left the combustion chamber. They are traveling through the exhaust pipes and they're leaving the vehicle. But a small turnoff exists that allows a small amount of these exhaust gases to pass through the EGR system and back into the air intake of the vehicle. At that point, it will mix with the fresh intake air, and this mixture will help reduce the chemical makeup of the air entering the cylinders. There will be less oxygen. Therefore, the fuel mixture will burn at a slower pace. Therefore, the temperatures will be lower. Since the temperatures are lower, there will be less NOx produced when the gases leave the engine. To help cool this exhaust gas, that's where this heat exchanger comes into play. Hot exhaust gas enters, and on the other side, a somewhat cooler exhaust gas leaves. Now, on the other side of the heat exchanger, we have the engine coolant that comes in and takes some of the heat that it took off the exhaust gases and takes it with them. Here we have a closer look of the heat exchanger. Right here is the hole. If we take a look inside, we can see the nice metal shapes and formations, everything nice and clean. This is how it looks when it's new. Now let's take a look how it looks like after fouling has occurred. After 100,000 miles, we can no longer see the actual metals. We can see fouling has been deposited on every single millimeter of this heat exchanger. And after 150,000 miles, we can see that all these little holes that the exhaust gas was traveling through, they are practically almost completely closed up. At this point, this probably is not even functioning anymore. I remember when I was new to heat transfer, I always thought fouling was just some small thing that needed to be crossed out of formula so we can hurry up and solve the problem and move on with it, right? But in real life examples, actually it's very important for us to not just use the formulas where the clean surface is considered, but we also take into consideration the fouling that will occur as time goes on and the heat exchanger is in operation. Like here in our pictures, we only saw the fouling, for example, that was deposited by the exhaust gas. We would have had to cut open the heat exchanger and take a look inside to see what was deposited on the other side of the surfaces where the engine coolant is traversing the heat exchanger. And one last thing, there's plenty of tables in textbooks and other sources that we can find all over so we can make sure that we can calculate our problems in a more efficient and actually real life representative ways. Thank you guys for watching.